All right, this is your homework video to go over the 6 problems you have to do tonight, Monday, November 28th. So you've already done your homework and now you're just checking your answers. So let's get to it. The first one is a power of 10 problem. So we say, is that a power of 10 I see? Then all you got to do is listen to me. There's only one rule. That's not a lot. All you got to do is move that dot. So there's our decimal. And we're going to divide to the left, to the left, to the left. So we're moving it to make it smaller. How many times do we move it? Well, we look at that power of 10. We see a power of 1. So we move it 1 time to the left, making it smaller by 1 place value. And so our answer becomes 6 and 363 thousandths. Looking at number 2, we're going to round it to the nearest hundredth. I underline hundredths to remind me that's where I'm going. Hundredth is 2 places after the decimal, so we're looking right there at that 6. We're rounding it to the nearest hundredths. So we're going to find our place and look next door. 5 or greater? Yep. So we're going to add 1 more. All numbers in front stay the same. That 6 is going to become a 7. All numbers behind, 0 is your name. And so when we round 23 and 167 thousandths to the nearest hundredths, we get 23 and 17 hundredths because that 0 doesn't matter. Looking at number 3, find the value of the underlined digit. Well, we can see that the underlined digit is this 3 and it's in the tenths place. So it's worth 3 tenths. That was pretty easy, wasn't it? Let's look at number 4. We're comparing. So remember, we say line them up, line them up, because we're comparing. So the first thing we're going to do is we're going to line them up by their decimal, and then we start to compare from the left. 4 and 4, can't compare those. 1 and 9, I can, and I know that 9 is greater than 1, so that's my bigger number. So I'm going to make sure when I write my symbol that the side that opens is towards that bigger number. So we're going to put it this way. So our equation is 4 and 191 thousandths is less than 4 and 911 thousandths. So it's a less than symbol. All right, number 5 and 6 are our word problems. So we're going to read them and we're going to underline that important information. We're going to look at it like a human, make sure we understand the problem, and then look at it like a mathematician and find the math. A new video game console needs 39 computer chips. If a machine can create 839 computer chips a day, how many video game consoles can be created in a day? A machine can create 839 computer chips a day. How many video game consoles can be created in one day? So we're looking at this. Let's think like a human. We're not going to look at the numbers. Okay? We have a console. It's going to need some computer chips. We've got a machine, and it's going to create computer chips. So we need to know how many times that machine needs to work in order to get a console. So we're kind of going to be taking those computer chips and dividing them up, aren't we, into the different consoles. So this is a division problem. We're going to be dividing. But what are we dividing? Well, what's the total amount? The total amount is what we need. We want to create 839 computer chips. So we're going to take 889 computer chips, and we're going to divide them into those consoles. Well, how many does each console take? Each console takes 39 computer chips. So we're going to take 889 computer chips, and we're going to divide them into groups of 39. That way we can figure out how many consoles we need. All right, so I'm going to use my whiteboard because I need a little bit more room to do this one. Okay? It's time to divide. I'll tell you how it's done. Using partial quotients is a whole lot of fun. Set up your think box, hundreds, tens, and ones. Next, look at the problem because we've only just begun. So let me get my think box set up. Scooch this over a little bit. 3,900, 390, and 39. Okay. Using friendly numbers is the way to go. Put your number on the outside and your answer below. My hundreds numbers are too big, so we're going to my tens numbers. Okay, 10 times 39 is 390. I bet I could go a little bit higher. Let's look at 20. Again, I'm going to use that trick of just multiplying it by 2. 2 times 9 is 18. 2 times 3 is 6 plus 1 is 7. Add your 0 and your 0. That's 780. That's pretty good. Should we do 20 or you want to see what happens if we do 30? Okay, well, let's try 30 and just see what happens. 39, again, my trick, 39 times 3, 27, 9, 10, 11. Too big. So we're going to cross that out. So we're going to go with the 20, right? Put your number on your outside and the answer below. Subtraction comes next. Yeah, you know it's getting real. We're trying to make the dividend completely disappear. Okay? Keep using friendly numbers to subtract the dividend. So, can I use any more tens? Nope. So now I'm down to my ones. I want to get as close to 109 as I can. Okay. So let's think. Well, 1 times 39 is 39. So let's go halfway. Let's go to 5. 39 times 5. 5 times 9 is 45. 5 times 3 is 15. Way too big, right? All right, so let's drop it down. Let's drop it down to 3. Oh, I already did this one, didn't I? 3 times 9 is 27. 3 times 3 is 9. 10, 11, 1, 1. I'm getting close, but I'm not quite there. So let's try 2. 39 times 2. 9 times 2 is 18. 1, 8. 2 times 3 is 6 plus 1 is 7. 78. All right, so let's try that one. Put your number on the outside and your answer below. Subtraction comes next. Yeah, you know it's getting real. We're trying to make the dividend completely disappear. All right, keep using friendly numbers to subtract the dividend. When you can subtract again, then you know you've reached the end. Let's wrap this problem up because you know it's getting late. Add up your friendly numbers. There's your answer. Man, you're great. Oops. So we got a remainder of 31. I can't put 39 into 31, so I know that I'm done. So my answer is 22 with that remainder of 31. All right, but let's go back to our problem because we don't normally have remainders in the real world, right? The remainders mean something. So let's go back to our problem, okay? All right, a video game console is going to need 39 computer chips, okay? If a machine can create 889 computer chips in a day, how many video game consoles can be created in a day? Well, we separated out. We got 22 groups. That means 22 video game consoles. But what about this extra 31? What is that? Well, those are the 31 chips that were made. Can that be put in a console? No, we need 39. So even though we created 31 extra chips, it's not a console. So that does not answer our question. This answers our question. We need 22 consoles created. So going back over here, again, we're going to label our answer. So our answer is 22 consoles. All right, not too bad, right? Let's look at the last one. The booths at the state fair make $766 an hour. That's important. I should probably underline that. I'm going to double underline an hour. How much money would they have earned after 87 hours? So for every hour, we earn 766. So for the first hour, it's 766. For the second hour, it's 766 plus 766. For the third hour, it's 766 plus 766 plus 766. Well, that's repeated addition. That means this is a multiplication problem. What are we multiplying? We're multiplying $766 per hour by the amount of hours, by 87. Okay, we can do this. So I'm going to go ahead and set up my problem, and I'm going to solve it like I solve all my problems. 7 times 6 is 42. 7 times 6 is 42 plus 4 is 46. 7 times 7 is 49 plus 4 gives me 53. 0 and cross out, right? 0 and cross out. 0 and cross out. Let's go. 8 times 6 is 48. Carry your 4. Bring down your 8. 8 times 6 is 48. Plus 4 is 52. Carry your 5. Bring down your 2. 8 times 7 is 56. Plus 5 is 61. Now we're going to need to add these up. 2 plus 0 is 2. 8 plus 6 is 14. Carry your 1. 3 plus 2 is 5. Plus 1 is 6. 5 plus 1 is 6. And bring down your 6. So, how much money would they have earned after 87 hours? This is money, so I'm going to label my answer as, whoa, 1, 2, 3, comma, $66,642. So there you go. There are your answers to tonight's homework. If you watched this video, what I would like for you to do down here in this little blank space, we're getting ready for the winter season, so let's give ourselves a pretty little snowflake. Oh, look how pretty that is. So if you watched the video, go ahead and put a little snowflake there to let me know. All right, I'll see you tomorrow in class.